Good afternoon, everyone. Welcome to Global AI Night, Bulgarian edition 2021. Probably you didn't expect that very soon we will have again event. Again, we are part of global event, this time on AI Microsoft community. And I'm very glad that this week we will be able to have three interesting sessions about artificial intelligence and related technologies. I will not spend a lot of time in this short opening. I would like to say again thank you to our team for this organization of the awesome event and to all speakers who joined to this conference. And we will continue with one very interesting session about bots cognitive services with Andre Melancia. Thank you very much and enjoy the conference.
Okay, so I think we are live as far as I can tell. Welcome, everyone. We are about to start the first session, and it falls on me to do it. So really happy to be here. One more time presenting for Bulgaria. This has been over 25 times that I've presented for Bulgaria. Really happy to do so. Just not happy that I'm not there in person to eat the amazing food. That's always what we expect in these kinds of conferences. But anyway, really want to thank Michael for inviting me to this session, and also Stefka, who's actually helping us, handle all of the background of all of the session and make sure everything is working okay. Anyway, today we're going to talk about things like IoT later for the other sessions, things like cognitive services here. We'll quickly talk about bots as well. This is interesting, all mixed together as well. A few months ago, I can't remember the exact date, but maybe 2 months ago, in Power Platform Bulgaria, I actually did a session which is online, focuses exclusively on bots. So I would recommend everyone to go and have a look at that on YouTube as well, because I think that this can be a very nice complement to the session that we're going to see today. But in any case, we'll start the session just in 1 or 2 minutes, just to make up the time to actually start it correctly. But in the meantime, I want to invite everyone, if you are joining from Facebook, if you are joining from YouTube, etc., to ask questions, ask anything you'd like, and I'll be very happy to try to answer all of those questions at any time. Okay, so we have amazing people joining us with me as well that can moderate the session and ask me any of those questions. So feel free to do so. Anyway, should I start now or wait 5 minutes until the session is supposed to begin? What's your take on this? Okay, I think... okay, wait 5 minutes or start now? Okay, so start now. So we'll actually start sooner. This is very rare. So both in Bulgaria and Portugal, we have a tradition of starting late, not early. This is very strange. But in this case, let's break the tradition. Everything is online, and let's start sooner and talk about more cognitive services. So you've probably seen my cat. This is my amazing cat, which usually goes around the place every time I do a demo. She'll probably be around sleeping. By the way, this is supposed to be an AI night, but here it's just beginning of the afternoon, so it's very strange. Anyway, feel free to see online some of these sessions I've already done. Most of them, if not all of them, already in Bulgaria. So this will be interesting for you to see. Sadly, not done in Bulgarian, but I am learning some one or two words, but not a lot, sadly. But then again, I can also do this in Portuguese if you'd like me to do the session in Portuguese. Anyway, let's talk about the session itself, and the session will be cognitive services. And of course, one of the things you immediately see on the screen is a car somewhere floating in space. Well, this is not a normal car. This is a car from the 80s, which was a very famous car driven by this guy with a different face, which used to be David Hasselhoff, doing something called Michael Knight, which was the name of the guy. He was driving a car called Kits, and this was everyone's dream in the 80s to have a car that could talk, that could drive itself, that could jump over things. So this was the main characteristic that everyone liked, which was to jump over things. And the car was supposed to be flying around all of the time. And then you would even have a smartwatch, which is something that didn't exist in the 80s, but a smartwatch that could actually communicate with the car and do all of the amazing things that watches nowadays actually have, which is amazing to consider. Now, if you come from the 80s like me, if you were in primary school somewhere in the late 80s and you used to see this thing, you were a big fan at the time, and you thought, wow, we need to have something like this. Funny thing is that 30 years later, we do have a lot of the things that you see here. For instance, things like tablets. These things actually existed in Star Trek long before, people came along with them in the early 2000s and things like that. And if you go to things like cognitive services, artificial intelligence, talking bots, well, in the 60s, you already had a film, actually before that, a book that used to be something called HAL 9000, which was a smart computer that was going on a mission to Jupiter or something like that, and actually went rogue and tried to kill everyone and things like that. So this is not new, but nowadays we actually have this for real. So this session, hopefully, will try to show you a few of the ways you can create some of these services that will kill humanity at some point in time. So let's see what happens. Anyway, this is me. You probably noticed that weird looking thing in the background, which is, like a flying saucer kind of thing. It is somewhere in Bulgaria. Yes, it was raining when I took that photo, and ironically enough, I took that photo in October. So I went there in October to Plovdiv and then to Sofia, and I did some sessions there in person, which was a short time span where I could actually go there physically and present those sessions. Currently, this is not very viable, but at the time, 6 months ago, this was viable to actually go there and present at SQL Saturday. Nowadays, I just have the memories, but hopefully in a few months, I will be able to join again and go there. And especially if there is food, if you offer me food, I will go there. No worries. Anyway, if you don't know what this is a very interesting monument on top of a hill, not very far away from Shipka. I think that's the correct word. Please correct me if I'm wrong, but I think that this is somewhere in the hills. And I actually went there alone, which was fun. A very pleasant alone trip in COVID times, renting a car and going to these places. Raining a lot, but I did see other people there trying to visit the same way as me. Anyway, if you need to contact me, feel free to do so. Just go to andy.pt or contact me via any of the usual channels. I'm always available to answer any questions from you. If you'd like to ask about cognitive services, about Azure, about anything actually, I'll be happy to help. And I also receive Stefke is actually mentioning that this is called Bozludza, which is the actual name for the thing. It's a very famous monument. It is actually guarded by policemen, so you cannot go in, but you can see it from the outside, and it has an amazing view if it doesn't have that kind of weather. Anyway, let's actually get to the session and talk about a few things. By the way, if you are curious, I am somewhere on this side, actually this side of Europe. I think that this is the correct way, in Portugal, somewhere in Lisbon. It's not good weather today, but at least it's not raining. A few days ago it was beach weather, then it rained, then it's back to normal again. So these COVID times are actually crazy. But then again, everyone's supposed to be at home whenever possible. So it's not supposed to be that fun. Anyway, let's talk about cognitive services. And the first thing you need to know is, what are cognitive services? Well, these are services that any developer can use. These are based on REST APIs. So that means that any developer that can connect to a REST API, to a web service using HTTP or HTTPS, can actually use these things. And yes, these are part of Azure, but no, these are not expensive. These are actually quite cheap. For instance, just to give an idea, for face recognition, you can recognize something like 1,000 different images with faces, and it will cost you something like €1 or €2. Can't remember the exact price, but 1,000 face recognition operations will cost you €1 or €2. And some of the other ones for the things we're going to see are even cheaper than that. So it's not an expensive price if you'd like to use this in your applications. And then, of course, if you use a lot, this is a cloud service, you pay more. If you use much less, you pay much less. There is also a free tier in which you can spend X amount of usages of each cognitive services. So all of them are different in this case in terms of limits, but you can have them for free. So you don't even pay for that. And you can have them for free for the rest of your life while you are testing everything. And for testing, trust me, the amount of values that you get for free are usually more than enough. Okay. If you need them for production, well, then you need to start paying for them. But as I mentioned, the prices are extremely, extremely cheap. So let's have a look at how this actually works. And then the next few sessions are actually going to talk more about things like IoT, etc. And obviously, if you want a talking car, you will need to go on the IoT way. This is not going to be the focus of the session, of course, but you will need to include some cognitive services. You will need to include some bot functionality, some interaction, etc. We'll try to talk about some of each individual component that you can use, and then you can build your own car. It's like having Legos, individual Legos, and you can join them together to build a car, to build a crazy robot that will take over the world. You can build any smart glasses that you can do things with, or you can simply have a chip implanted in your head. I don't recommend that just for now, but then again, if you take the vaccines and things like that, this is what people tell you that they are getting. But in that case, as long as it has 5G connectivity, I'll be very happy. Anyway, cars, as I mentioned, but then again, the simplest things that most businesses will require, which is just to be able to use a cell phone and interact with these kind of things like cognitive services and bots, things like a normal computer or laptop. So basically anything that has a web interface, a web browser. This will be simple enough, but you can also use this in a kiosk. And there is also some restaurants that you can go around the place where they actually have bots that bring you food and things like that. So all of those already exist. This is not new. They already exist. There is no limit to your imagination. You have all of the building blocks you need, and I will show you all of these building blocks here, or at least most of them. New ones come along every day. So if you see this session in 2 weeks' time, this might be outdated, and you might already have a new one, which is always very interesting to try out. Anyway, in any case, you can start by, let's say you have a cell phone. A cell phone is a good example. Or if you have a website that, for instance, has one of those things in a corner that says, "Hello, is everything okay? Can we help you?" etc. Those are usually chatbots, and usually have two types or three types if you want to go there. But the first type is a very basic chatbot in which mostly there is very little interaction. There is some intelligence that we can see from cognitive services, and that basically has questions and answers, like frequently asked questions. Those aren't very interesting because you simply go to a list of possible questions, try to figure out the best possible question or answer for that user, and then give it back, and you have a fixed answer for that. That's not very interesting from an artificial intelligence point of view, but it works. In most businesses, this will be more than enough. For other businesses, and by the way, let me just say this, that's have a look at the session for Power Platform Bulgaria that I did a few months ago. You can actually know how to do these kind of chatbots without one single line of code. You don't need even to be in IT to do this kind of thing. It's easy. You use something called Power Virtual Agents. Okay, so have a look at my session about Power Virtual Agents. You'll be able to find out exactly how to do that. Okay, but here we're going to take this to the next level. Okay, we're going to do a bit more. We're going to add some intelligence to this, and maybe do some more bits of things that you can do with just basic bots and basic functionality in websites and in mobile apps and things like that. Anyway, the second level of bots is when you have a bot where you write something randomly and the bot tries to understand the middle of the phrases. So let's say, "Please turn the light off in the living room." So they will actually detect that living room is a location, turn the lights off is actually an action, and then you might have a few other things like turn them off in 10 minutes or something like that, which can be a time reference as well. So all of those can be the next level of intelligence that any bot can use. This is actually called language understanding services, and it's one of the cognitive services we'll see just in a bit. And those are very easy to integrate with bots. And bots, anyone who does programming can actually create a bot. There's something called the bot framework. You can create a bot with that, so that's easy. The third level is a bit higher. So this is beyond these cognitive services. You have to do this yourself and make a bot as sentient as possible. So to make the bot as intelligent as possible. But this requires a bit more work from you, a bit more, AI knowledge, a bit more preparation, etc. But the first two levels, which are very advanced already, are something that you can do already. So if you remember things like Cortana, Siri, Alexa, etc., these are level number 2 that we talked about. All you need is something similar to language understanding services to program a whole bunch of functionality, and then that will work automatically and insult each other's virtual assistants like Siri insulting Cortana and vice versa, those kind of things, being sarcastic about them. This is actually quite fun, but to be honest, this is programmed, okay? It's not that intelligent. The third level that I mentioned would have to be a bit more intelligent, but that would be Skynet taking over the world. So please don't go there, not just yet. It's been a crazy year, last year as well. Don't create crazy bots like that this year. Wait for next year. One problem per year, please. Anyway, let's see how this actually works. So let's say you have a specific scenario where you have, let's say, an app on a phone or basically a website, something simple. You don't really connect to the web services directly. This would be a bad idea. You actually have web services in the Azure cloud somewhere, but you don't connect to them directly. And the reason you don't do that is that they have an address to access the web service, which is the HTTP DNS address. So you go to port 80, port 443, but you need the DNS name to access. That will be the one. But if you go there directly, they will ask you for a key. It actually has different names and different functionalities like tokens, etc. You can use a few others, but let's keep it simple. It's a key or a password. Okay. And you will need that. If you write that in your application, anyone who does reverse engineering will be able to access that and use it. That's a terrible idea. So what you do is you have something like a proxy or a broker in the middle, which is 100% controlled by you, where that password is actually written down there, but it's not accessible for anyone on the outside. So how does this work? First of all, let's say you take a photo with your cell phone. You take a photo, you send the photo over to the green server, which is controlled by you. It can still be in Azure, no problem. Okay, but it is controlled by you. you authenticate the user in some way, let's say Facebook authentication or personalized authentication for a specific client. Doesn't really matter. You control this, no problem. And then you send this over from that yellow, from that green server. In fact, you send it over to Azure to actually ask for the information on that web service. That web service will do some magic and will actually process, let's say, take that photo and try to figure out how many people are there, what's their age, what color they have, their hair, or no hair at all. That's also a possibility. And then they will send this over again to the green server, which is controlled by you. Once you do that, you receive information in raw format. In most cases, this is going to be a JSON format, which is really easy to understand. It's really easy to parse. You have a whole ton of libraries for JSON, and these can be in any programming language you'd like. So even if you use COBOL, for instance, you'll still be able to use some REST APIs as long as you can connect to an HTTP or HTTPS request and use COBOL even, which is something that existed long before I was born. You can actually use that and process JSON and then send it over to the client. It is possible. Don't use it. It's like a really old language. There's much better languages, but still, if you use that, let's say if you are in the flying industry like airlines and things like that, or banking, a lot of people still use it, so it might be necessary. But in any case, you process all of that information in your programming language of your choice, however way you want it, and you get the information back to the user in some way. But this time, that number 6 that you see there is actually sending the information in some sort of processed way. So you only give them what they actually need to see. You might just give them something graphically, and we'll see a few examples. We'll actually use we'll do some of the demos in a website, which is actually Azure website. This wasn't created by me. This was created by Microsoft to demo things. So we'll actually be able to see some of those things there. And this is exactly how they do it. Okay. They have these kind of flows of information. You upload something and then they will process this for you. You never get to see the cognitive service. All you see is an interface in a green web server, and that's all you see. Everything else is just transparent, and you just assume that it works. Okay, so this seems very simple, but let's have a specific demo. Anyway, as you probably remember, there used to be a button in that car, and I missed that button. This was very nice, and it was something called Turbo Boost. Whenever you pressed it, you actually had cars doing this. And if you were a kid in the 80s, this was something that you needed in every single car. Okay, by the way, there are people actually selling those kinds of button places so that you can put in the car. And actually, some time ago, I was doing this session somewhere, and a friend actually posted on the chat a link to actually buy a car like this, a fully functional normal car. Just the buttons wouldn't work. That's the only thing that wouldn't work. But if you want to buy it and then take those buttons and actually make some functionality out of those buttons, please give it a try. Personally, I would like to have a car like that, but it's a lot of work. Maybe I'll stick to trying to buy the USS Enterprise or something like that. But then again, wishing a lot. So let's have a look at some actual demos. Okay, so let's make this interesting and fun. And this is something which is my Azure Portal. I have a dashboard. I have a few things here. Most of these things are for testing, so don't worry. I'm not showing any personal information. Somewhere here on the right, I have some cognitive services. This is how you deploy them. You press the plus button, and then you ask to deploy some service. I'm just going to show you for one. All of the others is basically the same. So let's say if you want to deploy a face recognition service, all you have to do is to press the plus button, which is create a resource, which is basically this create a resource, and just say create the face button. But wait a minute, how did I get here? So to actually get here, and your question might be, oh yes, but I'm going to Azure, but I don't have an Azure account. This is terrible. Yes, this can be a problem. Okay, I do understand that that can be a problem, so you can get one for free. Is that okay? Hopefully that's okay. So you go get started for free, you press the button here, and then you press the green button again, and then you click start for free. Now, what you get is when you start for free, you have 150 pounds here, but if it is in euros, I think it's a bit more, or actually a bit less, 130. If it is dollars, it's a bit more. So whatever your currency is, the real value will be always very similar. You get it for 1 month, 30 days, but then for 12 months, you actually get a lot of other things for free, like virtual machines for a number of hours, SQL databases. I don't know. You have all of these things which are free, and some of the products which are continuously free are things like Azure Functions. And by the way, a lot of times you actually use Azure Functions, and then inside of that, you actually call cognitive services. These are great, for instance, when you receive some IoT requests or something like that, and you need to process them using cognitive services. Let's say you receive a face from an IoT device, and then you send it over to an Azure function, and then Azure function will call the cognitive service with that image, etc. And then it comes back and gives you the information you need, stores it on a database, stores it somewhere in Cosmos DB, for instance, which is a NoSQL database. But in any case, you will use it in some way. Doesn't really matter what it is now, but you will use it in some way. And although it's not listed here, it will be on this full list here. You will get access to a whole bunch of cognitive services for free. And we will try that just in a second. So there are no reasons for you not to have an Azure account. It is free. Try it. If you already have an MSDN or a my.visualstudio.com account, you also get free credits every month. If you are a university student, you can just use your username from your university, like your email address from your university, and you can also get credit for free. So no excuse not to try this out. It is free. Use it. This is fun. Okay, just don't build a Skynet and kill us all with free credit. That would be very frustrating. Anyway, you select the subscription. A resource group is just a box that you put things in. So let me just go and see if I have one already. So let's say this one is there already. I've created some things there already. You select the region, doesn't really matter. You give some name like face something, recognition thing, etc. Doesn't really matter. I'm actually not going to create it now, but in any case, you can choose the free tier. So that means you get 30,000 calls per month. That's something like 1,000 requests per day. That's more than enough for you to test anything that you need. So this is free. Come on, this is amazing. And anyway, once this is done and fix one or two other things about security, etc., you can just say review and create. By default, most of these things will be public, just to mention. You can have this as a virtual network exposed to the public, so all networks, including the internet, but you can actually reduce this so that people won't see this in a public-facing IP address, okay? Review and create, and then you create it, and then you use it. I'm not going to go into a lot of details how to use this, but there are some nice wizards to actually do that, so you can try this out. For instance, this was the created version already, and then you have a quick start here, how to explain the things, okay? So get the API keys, which are keys that you can see here. So these keys will actually be here. I could click the show keys, get the keys, and then use those keys to access everything. This is, for instance, the address that I'm supposed to use, plus one of these keys. You can actually access those services, but then you have a quick start in most of these cognitive services, or something saying build this or something like that, and then you can just try these out. You can see some quick start examples in C#, in Python, maybe sometimes in different languages, and you can start this out. But this is all very nice from a programmer's point of view, but I want to see actual examples. So let's do this. So first of all, we need to go again to the Azure Portal, to the Azure website, in fact. And from there, we can actually go and try to find, let me just go and have a look. So this is products, this is AI machine learning, this is cognitive services. So you need to follow the steps: products, AI, machine learning, and then you have a whole bunch of them right here. So you have quite a few. Let's try to talk about each of these. By the way, let me just say that it might be a bit difficult for you to create a flying car, because the flying part of the car might be a bit difficult for you to do. It involves something called the laws of physics, something like that. But in any case, everything else that's available in the car, like surveillance and things like that, some of the things you can actually pull it off with current technology. Okay, so give it a try, and let's look at this from that kind of point of view, or maybe from a point of view of something that you would like to create using these services, and let's see what happens. So we have a few different types of categories for this. Let's start with a simple one, which is no longer called web services. So let's get rid of this ones already. And these are something called Bing Search APIs, which have a whole bunch of them, like the same way you have on Google for searching images and things like that. Okay, yes, everyone knows that Google is better for searching for images, searching images and things like that. Come on, everyone knows this, but Microsoft does a lot of better things in things like translation, other cognitive services as well. Microsoft actually does a lot of things better in that sense. So in terms of Bing Search APIs, these are still interesting if you want to include them in your applications. Maybe not the best, but they still work, so it's okay. I can recommend two which are not related to search, which you'll find if you go here. I'm not going to do that, but this is one which is something called Autocomplete, in which, let's say you have an application and you start to write in your application, it can actually trigger some autocomplete so that you can complete the word or something like that. It will try to help you out to complete sentences and things like that. That's one. Second one is something called spelling checker, or something similar in terms of name. They keep changing the name for that. That's also very good because you write down a text and you want to validate if the text is correct for the user and give them some underlines, let's say one of those red wiggly lines to say, oh, you've written this incorrectly or something like that. That service will actually be able to do that for you. Okay, so let's get rid of these Bing APIs. These two are especially interesting for you to try, but let's actually try the ones where Microsoft is actually really good at. Okay, so let's give them a try. Let's start with vision. And by the way, if you are someone who has done things like machine learning and you are familiar with concepts like that, you don't need most of these because all of these are trained by Microsoft already. You don't need this kind of thing. You just need to use them and consume them. Let's start with face. So face recognition is easy, and you start with face recognition by going here, and you actually have an example. This is a woman. It just has a rectangle around her face. Not very interesting, but this is because they're using detection model number 2. There's quite a few detection models and different parameters that you can configure on cognitive services. The things that you see here on the demos are only a very small subset of all of the things that you can actually do. Okay, so in any case, although detection model number 2 gets better faces and finds better faces, you want detection model number 1 to actually give you details about each specific face. Okay, now to do that, let's say that this case specifically, you have color of hair brown. That's 99%. Well, it seems to be true. I'm going to agree with that. And then you have things like female, age 25. Well, I'm not sure about the age, but then again, yeah, all of the rest seems okay. No mustache seems to be right. No beard, no sideburns. Yeah, I can agree. Okay, head pose. What's that? It's the position of the head, up, down, 3D, tilted, whatever. All of that position of the head. This might be important if you ask the person, please look straight. I'm not sure if you have that in other places of the world other than Portugal. You probably do, but here, if you need your ID cards, you have to go to a machine and look at the machine straight on, and then if you look to the left or to the right, or even if you are smiling, they will say you cannot be smiling in this because you're not supposed to be happy with bureaucracy. But in any case, you can use cognitive services to make sure that people are actually looking to the front with the eyes to the front and things like that, making sure that the photo will give you all of the necessary information about the face in legal terms, let's call it like that. So, okay, the smiling part is no one likes people to be happy about bureaucracy. That's just the thing. But there is a way to fake it, and in my ID ticket, I actually faked it. So I am smiling at that, but it's not very normal. You usually look like someone who's just left something like a prison or something like that. Anyway, other things like reading glasses is something, emotion, happiness. So she actually seems to be happy. And all of the rest is then a few things like blurring level. The blurring focuses mostly on the face, not around. Obviously around there's blurring, but the face itself is actually a good level. There is no noise. There is no pixelization, some weird things. There is no problems there. And then you have a lot of face landmarks for each person, so that makes it easier. By the way, she has a specific face ID, But if you go here, and if you go to, let's say, this one, which actually has a lot of people, and in this case, it has 3 people, let's say a couple and the kids, and let's assume, so Face ID number 1, it says male, age 26, so I'm assuming it's the guy right here, so I'm not assuming it's the kids. Anyway, male, no glasses, this seems to be true for everyone. Happiness is true, so that's fine, okay. Lip makeup seems to be true. Well, this is a stock photo, so maybe they did that, but not eye makeup apparently. But let's go to the next person on the list. Face ID second person, whoever that is, we'll figure out. And color brown for hair, 99%. I'm assuming it's her, but I could be wrong. The kid is also with brown hair, lighter brown hair, but still brown. And this is female, so yes, it is going to be her. No, 32 seems too old for her. I think she might be younger, at least in this photo. Anyway, no mustache, no beard, no sideburns, etc. Emotion, happiness as well. They are with a kid. I'm assuming it's their kid, etc. And they seem to be happy like any parent would be. But then let's have a look at the kid itself. So as any kid would be in such a photo, the kid is not happy. Okay, so the kid is going to be, let's say, color brown. Well, that's true. It is brown. The other guy is kind of bald, or at least shaved his head. But the kid is brown hair. And male, age 1. By the way, age less than 5 years old, very difficult to predict. Age older than 65 years old, also very difficult to predict. No guarantees that has any kind of precision. For anything else, in most cases, it's plus minus 5 years, which will be okay. But for a 1-year-old kid, this will be very difficult to predict. Okay, but in any case, the kid doesn't have any glasses. Plus, let's see, he has mostly surprised element here. It says neutral as a first emotion, but he is 25% neutral, 75% surprised. So this makes sense. Anyway, you can actually try this yourself. So if you are watching this, please try this yourself with your own photos if you'd like. This is actually quite fun. And because, I don't trust Microsoft, I don't trust anyone, so I'll actually go and try some photos myself. Now, you probably remember this one if you've been to Plovdiv. Many of you probably did. I was there quite a few times, as well as in Sofia, so this is taking a bit of time. You probably remember this guy, right? And this guy will listen to just anyone who's there. This is somewhere in the center of Plovdiv, and this is actually me. And for some reason, this actually doesn't detect anything. Oh, this is terrible. I added this image yesterday, hoping this would be okay, but apparently this is not okay. So let's try someone who's doing the same as me. And let's try our good friends and happy friends, Mr. Donald Trump. So everyone likes him. So we'll try Trump. Wait a minute, this didn't seem to open up. Wait a minute. Let's try this again. This is what happens when you do live demos. Sometimes things don't work, so let's give it a try. Sometimes the website isn't perfect as well, so that can happen also. But anyway, you have male 59, a lot of facial stretching and things, so he looks younger. He is actually quite older, like 10 years older than that, actually a bit more. Not sure when the photo was taken though, so that I don't know. But then again, emotion, anger, we know this, okay? This is normal, okay? So anyway, let's try a different one. So we can try maybe a scared photo of me. So I'm, for some reason, this guy doesn't really like me. This is very strange. Okay, so let's try someone you probably already know. So one of them is Michael, the organizer of this event. This is me somewhere in the middle. This is my tongue, by the way, very important to mention. Otherwise, you wouldn't recognize it. And this guy here, also a very big fan of Bulgaria. It goes there a lot, lives in the next country. This guy called Catalin has a lot of cats. Anyway, let's see what happens. So age 41, completely wrong. He's over 50. Age here 49, completely wrong. At this time, this was in this was taken in Poland or something like that. So I was about 40 years old at the time, or even younger. So this is wrong. And with Michael, I think this might be correct for that time. I'm not sure. Please correct me if I'm wrong. Anyway, but still, you can see all of the people. This is okay. Try this for yourself. Face verification. This is the next one. So you had face detection. You detect each face, etc. Let's go to face verification. And this is how you compare two faces. Now, ideally, you'll have one face only for each side, let's call it like that. But let's try maybe Borat. Borat is okay. And let's try with Borat. This is the real actor. Sasha is the real actor. Borat is just a character. If they compare to this guy, it's completely different. By the way, only 8%. However, if you go and browse a completely different one, which is this guy, who still tries to look a lot like him. So from a visual point of view, from a distance, you would actually say that these two are the same people, but no, this guy is completely different. By the way, fake mustache in both of these cases, anyway. At least the one on the left is a fake one. But the real Borat doesn't have the British flag in the lapel. But still, let's compare 33%. Not bad. Okay, so this is actually not bad. Please give it a try with yourself if you'd like. This is usually very fun. I'm just going to try with Trump, and I'm going to try with fake Trump just out of curiosity. The happy Trump and the fake Trump will actually account for 85%, something like that comparison. But let's try this with the fake Trump. So this will be the real Trump. Happy, which is rare, and fake Trump, which is from a TV show, and confidence is 55%. Now they look exactly the same in terms of clothes and things like that, maybe slight different of colors, that doesn't really matter. Hair is not that much different, it's actually to the other side. Then again, this might be the photo taken wrong, but in any case, they look very similar because this actor is actually very good. In terms of voice, he's actually very good as well, but in any case, these are completely different people. You can tell it in the nose, you can tell it in the eyes, you can tell it how the face smiles, etc. There are all of these landmarks that you can detect to know that these people are different. Okay, it is perfectly possible. Try this yourself. Okay, you will be very surprised. Anyway, let's try a few more. And then we go to cognitive services, but this time computer vision. And now I'm going to try my photo in Plovdiv. Now I'm going to try that. I did try this yesterday, so I know that this works for that specific operation. But before I do that, let's show the default one here, which is a train station or maybe a subway station. We don't know. And it says here vehicle, train, subway train, rectangle. Person. So there are people here, although they are all blurred, but you do have people, and then you have clothing, so they are dressed. So hopefully that's the case anyway. And yeah, they are. So they are people waiting at a train station. Confidence 83%. Yeah, that definitely looks like a train station. Although the photo is a lot blurred, you can definitely tell that these are the correct answers for this photo specifically. But let's have a look at and go and analyze texts. Let's try, wait a minute, uploads, and actually analyze image, in fact. And let's go for a different image. And in this case, I'll actually try, which one was the Plovdiv one? Here you go. This one I tried yesterday. I didn't try the other one. I was kind of trying to get lucky. My fault entirely. But okay, here you now detect two people. Okay, one is a statue, one is an actual person, or a very dirty looking person in any case, right? Anyway, what you do have here is you have a few more information. So you have people, let's see, a statue of a man. This is correct. On this side, there's also a guy here that happens to be me, but that's okay. And then you actually have a few more things like clothing. Yes, I'm not naked. Sculpture. Yeah, you can. Depends on depends on the language that you are using. English, Portuguese, Bulgarian. It depends. Well, that can be considered the sculpture. Yeah, I would be okay with that. Maybe more of a statue. But curb, it's actually the sidewalk, so it's also okay. So you can get this kind of value. Okay, let's try maybe one more. and analyze the image. And I could do a lot like cats. So let's actually try dogs, okay? And these are Dalmatian dogs. One of the first times I presented this was in Dalmatia, so I had to add these really nice dogs. And what you get here is animal, dog, mammal. So this is a generic thing. So dog is very specific. Animal is a bit of a more general term. Mammal is also a bit of a more general term to dog as well. And you get a bit more details as well. So this is easy. Anyway, carnivore, yes, they can eat meat. So that's reasonable. Then again, the same type Dalmatian. So yes, you can actually get it right. These are puppies, really small dogs. So puppies is correct. And then you also have here a close-up of a dog. It's actually two dogs, but then again, the explanation is not that bad. Okay. By the way, a few things to add in this picture that I didn't show before. You have things like gory. So if the image is scary, you have gory. Let's try one gory one. You also have black and white and adult content. So if you have something like a naked picture or something like that, that would be adult content. Black and white is, well, kind of obvious. Let's try a gory one. So a gory one would be this, like a really nice vampire coming in from Transylvania. And if you go here, technically might be considered a mammal at some point in time. Then again, the face of a dog, that's not entirely true. But sometimes these things are cute. But then again, gory, true, gore score 99%. So this is supposed to be scary. So if you are a kid, maybe you want to prevent kids from seeing this kind of thing, etc. This you can use for moderating things. There's actually something called Content Moderator that you can use some of these functionalities like adult content and things like that, racy content. So basically, adult content is if someone is naked, simple way of explaining this. Gory, that just means scary. And racy, that just means that it can be offensive to someone in different places of the world, but maybe not all of them, something like that. Okay. Anyway, this is computer vision. You can use it for a lot of things. Let me just show you one more. Recognizing celebrities is one of them, but I think that would be very obvious. Try this yourself. Okay. And let's try just one for reading texts. Okay. And reading text, you can actually try that with the golf carts. Okay. I usually have some of these examples to try out. The other one was a license plate. That was actually very easy. But this one is actually a golf cart. Let's open up this and see. Okay, easy go. So you have the letters E-Z-Go, something like that. So that's the name. Slander seems to be the text that's written here. And this ATAA, I'm not sure what that is, but it's actually written up here. It's actually not real, but this is the text here. I spent a bit of time like, where's Wally or something like that to actually find it. It's actually this thing here, so that really doesn't count. But then the license plate is fully correct. And then they actually have the details like birthplace of aviation, Ohio Bicentennial, etc. And if you go here, you actually zoom to the thing. Birthplace of aviation, wait a minute. Birthplace of aviation, 62, 1803, 2000, 1003. It's even weird for us, but the computer actually manages to see it. By the way, if you are curious about that ATAA, something like that, this is actually the thing. Okay, so this looked like letters, but this is obviously not correct. It's like a sun shield or something like that. But still, you get the idea. I think that this works mostly okay. By the way, you do have some JSON content out of this, and in some of the locations, you can actually go here and find that this text here, which is the license plate, is actually in this bounding box, which is the location somewhere here. So you can see it. It's actually the details. There's a lot of details for this, location, etc. So let's say you want to create one of those applications that translates texts. You take a photo of a text or real life text, and then up on top you actually have the squares and translate what's in the squares. You can call this computer vision and then call the translator at the same time, and then translate the text and put the text on top of that square so that you can see it on top of the actual thing. Like there's a lot of apps that you can do that immediately now. Anyway, let's try a few others. And the next ones you have, so we have about 10 minutes to show you all of this. Compute a forms recognizer. And forms recognizer is actually quite fun. Okay, so you can actually try to have some forms, and based on the forms, you can actually analyze the actual content. So there are some things which are predefined, and others that you can program this for yourself and select what kind of format you want to have. This one, for instance, you might want to program this yourself to be specific for your company. However, this one, like a credit card receipt or I don't know, a restaurant receipt or something, you can actually detect all of these values. Even if this is stretched like this, etc., you can actually detect some of these values and actually see things like line items, etc. You can actually see all of the details if you'd like. Okay, so this is very easy to use. If you need to scan a lot of documents like census information, we're doing census information right here. Although this is all going to be online, but in the past this was, writing crosses in forms and things like that. So when that actually happened, you would need to actually scan this. Most people, 30 years ago would do this in person, but nowadays you can do this online. Custom vision. So this is also very interesting, although this one requires you to do training, but this is very easy training. You press a button. How terrible is that? So anyway, you upload a whole bunch of images here. You have some cans, a lot of different things. Sometimes you might want to get rid of the backgrounds. That would be a good idea, so that you ignore the backgrounds, but then you focus on just the specific can part. So you create rectangles around the specific locations, and then you train to detect like cans of drinks and things like that. And then in the end, you click the train button and then you publish the thing. And every time you upload an image, they will detect not anything else like, cups and things like that, but they will detect if you have specific the actual cans of drinks, but not anything else, let's say on a table or something like that. So just that specific part. Okay, this is very easy to use. By the way, custom vision, you can actually use this mixed with the bots, mixed with the other things, or you this one and the other ones as well, actually. But you can put this in an IoT device, for instance, if you use a Raspberry Pi or any other IoT device using Azure Iot Edge. So the next two sessions will actually cover some of this, but you can actually put this there. You can put this in an Android application or something like that, which is easier. I also have Video Indexer. So Video Indexer, you go to vi.microsoft.com, easy enough, sign in. You can use your Office 365 accounts. This one is probably the most expensive cognitive service of all, but still very interesting. And then if you go here to samples, you can choose some of the videos which are already here. I always use the same for demos because this is the video that I'm more familiar with. I use this Build 2016 video. Okay. By the way, this is a 3-hour video, so this is not going to be perfect. I'm not going to be able to show you all of this for obvious reasons. Okay, but let's just freeze this for a quick bit. Wait a minute. So Video Indexer is going to take just a bit of time. I'm actually going to kill the sound because this will be bad for...
Well, good morning, everyone.
Okay, so this is Scott Guthrie for 3 hours. Actually, he only shows up in the first half of the session, up to 1 hour and a half, something like that. And then someone else takes over. So Kilu actually takes over the session, and then someone else, but he's only here for half the time. So if you want to go here to this place, you are sure that this guy is actually going to be here. If you want to find Scott Hanselman, and if you look into this location, you'll actually find Scott Hanselman there. So they actually detect the guy by the image, but also by the voice. So this is easy. A lot of topics, so you can find topics. These are not very interesting because they repeat a lot, like inventions. You have to read the video to actually understand what the invention is. So I'm not going to demo that. But then keywords like open source, Azure functions, mobile apps, etc., you can find them. A few labels as well. So you can find 500 and something labels just in this video alone. You can find dog, cat, fish, and a few others. Cup, flag, I don't know. So many things here. Chain, smoke, mustache. No idea where the mustache is. Maybe a guy. I hope, anyway. Beard, mostly not a mustache, but maybe there's a mustache here somewhere. I don't know. Anyway, the guy does have a mustache, by the way. Anyway, you can also have emotions. Okay, so emotions will be something like, let's say, angry emotion. So that would be the red one. I'm trying to actually connect to that specific location. So at some point in time, she's actually looking happy in most cases. She might do a face like angry, or maybe she's saying something very in terms of voice, so something like that. There might be a scenario where they detect this to be anger. You can also detect some parts to be fear. Okay, so fear is not that much, but if you look at it, you'll actually have her, and she actually looks down or something like that, and she looks a bit scared. Suddenly she's a bit scared. So there is a moment in time where she's actually scared, and that counts. Anyway, you also have the timeline to actually see all of the details of all of the text that's actually happening in real time. So Yina is actually talking now, and somewhere here it's 2 minutes 29, and she's actually saying something. So this is actually scrolling up, which is okay. And you can actually download the whole thing, so images and text and things like that, in a format that you can use in your applications. For instance, all of these videos that are created and Stefka, Nicolette, Michael are actually creating a whole bunch of videos in the last few years. At some point in time, you can actually join them all together, use this kind of video indexer, and actually try to index every single thing people say, and just search for tags and things like that. So someone mentioned cognitive services 3 years ago in a session. So we can find it, we can index that thing, we can actually find that by speaker, etc. So that's easy to do. Okay, video indexer is probably the most expensive of all of the cognitive services, but it's very powerful and actually uses things like face detection, computer vision, even language things, etc. So it uses a lot of different things to actually get those results. Anyway, we're almost at the end of the session, okay, but I still have time to show you a few more things. The usual things: speech to text, text to speech. Everyone knows this, so this is not different. Speech translation in real time. That means things like what you have now in Teams, or even in PowerPoint. Even you can add subtitles in real time. You are doing a presentation, and on top or in the bottom you actually see the subtitles in a different language. Sometimes they might not work perfectly because you need a microphone to actually capture your sound correctly, but if everything is working correctly, that should actually give you proper results in terms of real-time translation, etc. And this is based on this kind of thing. Speaker recognition is basically something where you have you upload a whole bunch of voices from speakers saying, hello, my name is blah blah blah, or something like that. So just speaking normally, and then they will detect the voice pattern, and then from there they will detect which person is actually speaking. That one is used, that speaker recognition is actually used a lot on video indexing, so that makes sense. You also have language, so you have immersive reader, which is actually good for people who have cognitive disabilities, or maybe there are just kids who are very young and are learning to read and write, for instance. That could be okay, and you can actually see the results in something which is an immersive reader. If you use Teams right now, there's an option somewhere on top that you can actually ask to see things in the immersive reader and see things like this. And if you don't know a word, you can actually click on it and have a definition of the word show up, or even say it out loud if that makes sense. So this is great to help people with disabilities, with learning difficulties, or just as I mentioned, anyone just getting started, like 6-year-old getting started with reading and writing. That would be okay. Anyway, we have Q&A Maker, and I did mention a bot where you had some questions, you had some answers, and then you could just every time a question was asked, you can give them the answer. So Q&A Maker is not that much different than that. It has some extra functionality, but this is actually the basis for that bot specifically. This is the service that the bot calls to actually get that frequently asked questions bot way that it looks. Language understanding is also very easy. It's what the bots are made of, okay? And okay, so we actually have, let's say, turn the right light on, and that means that you have something like intents, which are basically actions or verbs, and this is turning it on. This one is turning it off, okay? And you have entities or parameters in which you say, oh, it's the type of light, but it's the table light, the one on top of the table. Or if you say, turn the floor lamp to green, so it's the type that's on the floor, and it's the entity which you change color to green. So basically, entities are parameters, if you want to call it like that, okay? Anyway, one or two more just to finish up. You have text analytics. This is also very nice. Actually, for text analytics, you could spend a whole hour talking about this. We don't have that much time, to be honest. But here you have a text, for instance, and you can analyze the language. That's obvious. The key phrases. So all of the entities that are there and key phrases that you want to use to detect things. Sentiment analysis, if they are happy or not. So there's one here that says the only complaint I have, blah, blah, blah. So all of this is positive in all sentences, except sentence, not the last one, but the one before that, which is actually negative. Last one is very positive, so that works. And then the whole document has an average, which makes sense. Some named entities, so steakhouse, location, New York City location, dinner party, cook, owner, person name, kitchen, foods, addresses, etc. So you can detect all of this, and you can even go to the JSON file, find out exactly where this starts and ends. And if you want to censor, like for personal identifiable information, you want to censor the email address, you can actually do one line of code that goes there and replaces that all with X's for privacy reasons, for instance. So that's interesting. Anyway, we have the translator. We all know Bing Translator. Trust me on this, it's actually the best, works really well. No need to demo that. And finally, you have 4 other things which just I want to mention very quickly. So content moderator, you have some images or you have some written text, and you want to detect if you have some profanity, like saying some bad words, like starting with F or any other, or having something which is naked people or something like that. You want to moderate that, so that will detect it, and you can integrate that with anything you'd like. Okay, so that's very easy. You also have anomaly detection, completely different thing. You can do this with machine learning, but this one you just have a web service where you supply information, and then that information will detect if there is any kind of problem at some point in time. And if there is a problem, they will notify you that there is something that's gone wrong outside of the reasonable values. Okay. You also have metrics advisor, which is actually based on anomaly detection. So these two share the same kind of code behind it, but this one goes a longer way, in which you can detect things by time series and things like that. You can actually predict what's expected in the future, etc. So there's a lot of extra knowledge here, and this is great for applying to businesses, for instance. Okay. Final one is just a personalizer. So personalizer, if you have an application, if you'd like to see things in a personalized way, so let's say the instead of just saying the most recent documents you used, you say the most interesting documents that you probably want to use. Same like recommendations in YouTube or something like that, to recommend you with some videos. So personalizer can optimize your applications to look good. One last thing, which is the bots. I'm not going to go a lot into explaining the bots, so just go to the session for Power Platform Bulgarian. I think it was in February, and you will see a lot for bots. I'm just going to quickly demo an example of a bot. You can, once you created a web app bot in Azure, very simple to do, you can just go here to test in web chats, and then you can go here, and once this is done, you can say, let's say, this one is for booking a flight, book a flight, okay, and they will just start asking you things. Where would you like to travel to? Bulgaria. Where are you traveling from? Right here in Lisbon somewhere. When would you like to travel? And I really, really like to say this. Yesterday. No time is sooner. So anyway, can you confirm day 23? This is actually 24, so 23 would be correct for yesterday. You could just say yes, and then they will call a database, do something, create tickets for you, and you would get your tickets. So you can have a very simple chatbot like this, or you can make it very complicated. This uses something called the bot framework. You can also use other things like the bot composer, and then if you want to debug it, you have the bot framework emulator. These are some words you'll probably hear about it. So just search for these terms, and you will find everything you need, but you can get started here or use Power Virtual Agents. Okay. Now, just to finish the session very quickly, a few things. So if you want to build a car like this with these cognitive services, now you're probably thinking, okay, now I see that this is possible. Now I see that this can be interesting. So how can we build it? Well, a few examples. Remember the door opener? where they actually verified the face of the person. You can actually verify if the person is the correct one, or maybe by voice if you'd like, but face verification is okay. License plate verification, object detections, traffic signs and things like that. You can actually detect that by using video. You can use video indexer to actually detect people if you are doing spying things, like in some episodes. It doesn't see things through walls. That's just part of the film, but it can see things if you actually have a camera and use it. Anyway, you can also do a few other things like talk. So a web app bot, a generic bot, basically. Language understanding services, which we talked about, so that you can understand what people are saying. Q&A maker, if you just want a frequently asked questions bot. And then a speech to text, text to speech. That is actually important. You can do all of the things that we saw in language understanding services, for instance, but using voice. This is especially important if you have some IoT devices here. So the transparency is not very good, but you get the idea. You can have some IoT devices and try them out and add that to the thing. So basically it's just doing the text part, and then you add the voice as an extra. Okay, it's not difficult at all. It's just adding one more piece. Very easy to do. And then to actually speak the response, that's even easier than to getting the text coming in from the person's voice. Anyway, text analytics, if you want to detect if the people are happy or not, you can integrate that with the bot, and the bot can say, okay, I can tell by your voice or by your talk that you are not happy with something. How can I help? Or I don't know, something like that. If it is a bot for business, you can simply say, okay, this person does not seem to be happy at the end of the interaction with bots. So maybe you get a human to analyze the conversation and see if there's something I can do in terms of customer management to help that person. Okay. Anyway, translator seems obvious. People have different languages. I've been to Bulgaria a whole bunch of times. Translator helps, although nowadays I can actually get by and I can understand all of the signs for restaurants and things like that. So those are easy. Anyway, things like anomaly detection, metrics advisor. If you actually have a car, you might want to use that for detecting anomalies in terms of, temperature of the car, engine, something normal that's a perfectly normal car would have. This exists in a lot of places, but you can add the functionality to it using cognitive services as well. So anyway, you also have things like Personalizer. So you might want to personalize the way that the car looks, the way that it behaves. So if you have 2 or 3 different people driving the car, some cars already have this. You might want to personalize the experience for each person. Let's say I have a cell phone. I like bots to talk to me in British English. So very good, obviously talking like the Queen, of course. I don't like the American style of saying things. It's terrible. But anyway, you can have any way that the bot talks to you. And if they detect that this is a different person, they can talk to you in a different language, in a different voice, anything you want. Okay. For instance, although this is obviously awful, in some countries of the world, to actually have a woman's voice show up in one of these things is considered bad or something like that, because these people are a bit backwards in terms of civilization values. But in that case, you might have to have a man's voice. In normal cases, a woman's voice is very typical for Siri, for Cortana, etc. So if that's the case, or if you are a woman and prefer men's voice or vice versa, also perfectly okay. You can use the personalizer to adjust all of these settings and make it look good for you. So whichever way you feel nice about it. Okay. Anyway, I'm all done with this, but I am available for questions. Okay. If not here, so if the next session is actually about to start right now, but if you'd like, you can actually have interaction with me via social networks and things like that. So because I'm actually really over time, I do apologize for that, but I'm going to eject myself and leave the session for the next one. Okay. Okay. So anyway, thank you very much, Stefka, for helping out. And especially Michael, thank you very much for having me. And for everyone else joining, feel free to see the next 2 sessions. These are going to be very interesting. Think about them as a whole. You can use all of these services together, cognitive, IoT, etc. Think about this all as a whole. All of the conference as a whole thing that you can use for yourself. So thank you all very much for watching, and see you next time, maybe in person. Okay? Thank you all.
Hi, everybody. Okay, am I on air? Yes. Hi, guys. Andre, it was a very, very interesting discussion, and I'm really keen to see how to combine some of it or all of it in what we do, because we increasingly start to look into vehicles now. So, my name is Andre, like Andre, but at Y at the end, and I'm super happy to be here. I'm super happy to be here for yet another year. So thanks to the organizers, thanks to everybody who took the effort to participate, and I look forward to everyone. Okay, let me see what's visible now. Just to find one small glitch, just 1 second, to see what needs to be basically shared. Yeah. Okay, perfect. So as usual, I'm going to talk about practical applications of AI, stressing on Azure AI in practical life. And over the years, I've been talking about the practical application of AI in identifying and describing different assets. Now, with the years and with some real business applications, we tried to start to look into what we call relationships, because in modern worlds it's not enough to describe only the assets, but also how they behave with each other in increasingly complicated manner. As you quite know, some of you, I talk quite a lot about applications in the energy field, especially now in the modern times where we have to really start thinking how to integrate the ever complicated landscape of renewable energy, conventional energy, ways we use it as consumers, and how it affects our life, anything from food to energy safety, and where is the IT in the whole thing, and how it basically commands and controls what we plan to do now and in the future. What I like about my topic is that when I started about 4 or 5 years ago, it was quite rudimentary and it was quite in the beginning. Now, basically, the future came to play, and it came to play much faster than we've expected. One of the problems is that the landscape, as we describe it, basically is not unidirectional as we have used before. Basically, energy is being produced somewhere and flowing in a uniform manner to the consumers. Now, consumers becoming prosumers, and now we have a very complicated multi-directional flow, not only of power, but also data, which requires a very comprehensive look how the whole ecosystem operates, which lately it's only possible using artificial intelligence and machine learning algorithms, because one of the problems that started to appear more and more is not only how do we manage and run it, but also how do we simulate future events that may impact the traditional mundane things such as electrical grids and electrical power generation. Basically, we've evolved again from describing different assets and different ways how to manage to a new phenomena called digital twin. And the reason we start to talk more and more about digital twin is because the system has never been so complex. Well, for example, we now are quite used to electrical vehicles, and few people know that the number of electrical vehicles worldwide is expected to grow from about maybe 5 million around the world that we have right now to more than 120 million by 2030, which is literally across the corner. And if right now all of those start charging at the same time, it will literally destroy the grid as we know it. And basically, one aspect is how do we handle loads? The other aspect is where do we put the proper resources, whether it be money, human resources. Some of those can be super capital intensive, like transformers, grid lines, and where do we put it, and how much it needs to be utilized to make sure it doesn't break and it really serves the purpose of actually improving the way we operate, the way we move, the way we live. Now, to meet the challenges that we see on display of the modern grid, now we could finally need a very comprehensive view, not only how the network behaves right now, but also what can happen in the future, so we can all benefit by all those new exciting business cases. We're talking a lot about, independent power generation. We're talking about new distributed agriculture and way we make food. We're talking about how do we move, and we basically move the whole electrical business mobile. And what we need to be able to do now is to connect the different existing data silos, whether it be geographical information system, demand management systems, dispatching systems, and put them into one platform and basically understand how they operate, but not only understand how they operate, but also find what will happen to them in the future. So we need to learn how to simulate. And one of the problems is that different departments, and it's a very, very simple but quite representative picture of different departments, whether that's network planning department, grid planning departments, GIS systems, they're all super disconnected. They have very specific views of how the grid should operate, and basically we run into like the number one challenge to any digital twin, which is data silos. And traditionally, it's one of those businesses that still have almost zero interoperability. Basically, we have the need, we have the realization of the need, but we have a lot of legacy system, a lot of legacy infrastructure, a lot of legacy data, and absolutely no idea how to make it work without breaking it. Again, we can't play easily with the electrical distribution grid because we literally risk lives and health of millions of people. So the modern grids, they need to reduce those inefficient business processes and eliminate this manual data sharing, which, by the way, is also a way to unlock completely new services and revenue models, vital for basically their survival in the environment of all those pressures, prosumers coming up, new incumbents to the business, which basically means new companies that have absolutely nothing to do before with electrical grid transmission and distribution business coming into play. So what we have is a perfect storm combination of existing data, a lot of impact, and urgency, which we need to put in place to be able to move forward. To make it even more complicated, it's not only about future simulation of future events. It's also about how do we basically combine all those sensors that pretty much exist, whether our own sensors or sensors in mobile phones shared by people that are increasingly moving into the grid, and how to achieve this convergence to enable real enterprise data management. So to move forward and complete the current apocalyptic picture of how it operates, this is a very, very traditional data structure, right? I mean, up until now, you basically can observe it's a very, very typical hierarchical standard tree structure with parent-child relationship, which is quite uniform across all of our databases in our grids, where, for example, a unit, a cooling tower has, a very, very specific and rigid fixed relationship to a pump. And until now, and as part of my previous research, we've been trying to analyze how to detect those relationships, how to extract data patterns, and how to help with some, simple things such as, all right, let's, for example, forecast the life cycle of a specific product so we know when to change it and basically make sure it doesn't break. At the same time, optimize the cost of replacement so we have a business case. And right now, the structure cannot exist anymore because, as I spoke before, we suddenly need to integrate a number of other units, devices, events that basically have absolutely no interoperability until now, and they don't necessarily have to share any comparable data structure or even any logic to their operations. But they're super important for the impact of what we do. And here comes the role of the artificial intelligence, and I will talk a little bit more specifically what are the Microsoft advantages and what are the Azure different platform advantages when we apply them to this type of complexity. Basically, again, all the elements of a successful grid operation, anything from maintenance to security, proper energy management, they basically are so interconnected now that to compromise one of them means that if we don't apply sufficient control, we would compromise all of them. And basically, we can run into some disaster situations that are becoming increasingly more probable, because right now, if we don't have this comprehensive look how this operates, what are the impacts, how to use it, how to maintain it, we can run into a situation where adding technological complexity and IoT devices will actually increase the probability of somebody either hacking the grid or some malfunction which we will not be able to repair. So the grid is becoming less resilient and more complicated. And one of the problems why AI is becoming more important is that utilities are also competing financially. So in Bulgaria, for example, in our communist past, there was absolutely no constraint on how much resources you have to put into the grid. Basically, what happens is in most post-communist countries, not advertising it, our grid is super robust. It means that we sometimes have 2 times, 3 times, 5 times the grid, but it's not the case with new parts of the grid. Basically, right now, you try to develop and you try to basically imagine the exact amount of grid you need for the operations, and you don't have the capability anymore to overinvest into in capital expenses required for the expansion. So this is how we started thinking about, okay, if we need to not only monitor the grid, but we also need to play with the grid. How can you safely play with an asset with which you cannot play with, right? And this is how we basically naturally evolved to the concept of predictive digital twins. So we hope, and I hope that I'll get some questions and some follow-up questions on that. The point is not to first provide more insight and diagnostic information, what is happening with within power grid environments, but also start thinking what can happen to the electrical grid and what future events we can connect, and we can basically, for example, hit the grid with a snow blizzard and basically see what happens. And we cannot predict that unless we start applying digital twins, and in very, very close combination with machine learning. So basically, those elements can be so complicated. And for example, here is a typical representation. It's digital twin concept by Siemens, which basically unite multiple departments, and they basically try to make them share data. What I can say that this currently operates in several environments, but this is basically not enough, right? Because right now, to be able to play with external factors, whether it be weather, whether that be human activity, whether that will be any geological cataclysmic event, or that could be part of a human activity, a war, or that would be an overload, or that would be a sudden predicted, for example, change of law, which will enable a lot of people to buy electrical cars, and suddenly everybody's going to change their cars. That cannot be addressed only by a digital twin that runs in the grid, okay? So what we need to be able to do is basically achieve this. And this is where Microsoft Azure comes into play, and the new concept that is being supported by Microsoft Azure Digital Twins is how to connect everything, the whole landscape, how to connect legislation, how to connect real estate, how to connect manufacturing with their specific loads, how to connect, healthcare with their specific demand for uninterrupted, supply of energy, and how to connect energy, right? So the energy is just a little tiny piece of the whole model, and suddenly we've ended up with the challenge to model the physical environment, pretty much the whole world, in a meaningful way. So which means that it's not enough already to simply connect inputs from IoT devices, let's say using Azure Iot Hub or whatever system. We need to enable a single kind of live interaction layer where, basically delivers insights across the entire environment. So basically, if anything happens on the legal side, if anything happens on the manufacturing side, which, by the way, it's a very interesting thing in Bulgaria right now. I mean, you have the coronavirus. Companies are becoming increasingly sensitive about profit loss analysis, and suddenly there's a surge of movement of manufacturing into Bulgaria. And if before we pretty much had no prediction that's going to happen, I mean, without the coronavirus, we probably would not have the multiple, maybe triple demand of what people are trying to put on as manufacturing on the left side, which will immediately affect energy, because they're putting a lot of demand, let's say, for baseload. Okay. Plus, if we have no idea where education and healthcare will lead us, we will not be able to predict what will be the impact of new buildings, factories, farms, energy networks, railways, stadiums, entire cities, right? And one of the problems of current systems, and is that they enable you to pretty much model a very specific digital twin. But our challenge right now is how do you bring those digital twins to life, within a live execution environment, which basically some people call dynamic business logic, right? How do we get actionable insights, right? And how do we integrate it with other data? Like Azure data can be analytics, AI services. So basically, what Azure Digital Twins has started to unlock, and this has been around for less than 2 years, it's the ability to upload and explore models, to create, upload, and edit graphs of twins, and basically visualize the twins graphs with a number of layout techniques, and then use Power BI tools to, for example, present it in a very simple, meaningful way, so you can simply get finance for that, right? The point which I'm trying to make is that you needed a robust system to be able to, when you edit properties of twins, to basically propagate any change across the whole ecosystem without creating, a story that simply will kill your whole model because it's not dynamic enough. There are certain obstacles, as I mentioned. The first important obstacle was the data silos. Second obstacle for digital twins is connectivity, and this is also something that's addressed by Microsoft. That normally for a digital twin, you need a connectivity that needs to be super fast, guaranteed, and available across the whole spectrum of human activities. And this is not entirely possible in any country, right? Hardware, there's a lot of computing power, which you can never know how much computing power you're going to need in the future, because the complexity can pretty much scale humongously. What kind of human resources is needed? And by making the grid more complicated, I mean, you also run into the problem of security, right? And that becomes also a challenge to digital twin right now, which by its very nature accumulates data, a lot of intellectual capital, and can be super expensive for companies. So data silos, expensive hardware, connectivity, and trained professionals to help you define your model. So this is where Azure Digital Twins come as a platform as a service. And basically what it does, and what makes it different from the IoT Hub is the focus right now is on relationship of different objects rather than describing the objects themselves, right? So it's kind of an end-to-end solution where basically you now can model any environment and start scaling your digital twin without worrying that the relationship can break or be compromised in a very scalable and super secure manner. Using other Azure tools, you can now connect pretty much any information from any IoT device or any existing business system. You have a very robust event system that can help you in a very friendly way, which does not require a lot of investment into human capital to build very dynamic business logic and data processing. And then again, integrate pretty much anything you want, right? To support you in that, we also rely on something called the digital twin description language. And basically, it's JSON, which makes it programming language independent, and it pretty much supports any. It's not exclusive to Azure Digital Twins, and it's super flexible. So it means it can cover any vertical. It's ideal solution for creating complex relationships, and it basically unlocks you to use higher order analytics, machine learnings, and run complex computations. Reason we call it a platform language is also it basically lets you describe any complicated model, physical world environment in a very simple language in order to achieve this. Remember about the standard data parent-child hierarchical systems, which is, we know it's not enough because you need to go back and update those relationships whenever you update the complexity of the model. Right. Basically, what the digital twin definition language is offering is kind of a neural network that helps you map the complex relationship between any objects, regardless of where they are, what they are. It can be equipment, any kind of infrastructure, space, action items, and this is, what brings it a little bit closer to what we've been describing as, the fundamental in AI. It's kind of, now resembles more the connections in the human brains and how it operates, right? So it's now not a fixed parent-child relationship description. It's more of a complicated system of interconnecting relationships, right? So, and it's pretty much the only way how you look at it, you can try to find the root, cause of the problem. And this is how you basically start connecting and using more and more AI for, and basically it's pretty much, like putting a real human to the services you want to achieve. Just to make it less of an R&D exercise and more of a practical application, I'll run a couple of videos just to indicate how practically Azure Digital Twin has been applied. There is a great utility called Bentley, and they've been recently taking a super edge on real-world utilization of Azure Digital Twin, and that will be the video I want you to look for. And then I will explain how basically we try to build it in Bulgaria with existing resources, where will be super welcome to join.
Heavy industries
1 second.
Okay. Welcome to our latest IoT demo. This is a recent project from the partnership between Microsoft and Bentley for Doosan Heavy Industries. Just like the civil operations demo earlier this year, this also involves Azure Digital Twins and iTwin. And what this application does is it allows engineers at Doosan to monitor and predict the renewable energy output of a wind farm located off the coast of South Korea. So we're going to dive straight into the demo. We start off in the town right next to the wind reality data we add to the project to give the model some context. Towards the left, right off the coast, you can start seeing some 3D models of the wind turbines. So there are 10 turbines in this model, and we're going to be able to view the live power produced by each individual turbine. Now, where does this live power come from? The live data, that's a common question, and that's where the Microsoft bit comes in. We have an Azure Digital Twins instance that keeps track of all the sensors connected to each turbine. And we're able to query this data from our iTwin app and present it in a meaningful way. So let's go ahead and see what that will look like. We'll click on this Performance Watchdog tab, and this immediately starts fetching live data from ADT. Right off the bat, you can see the overall power being produced by the wind farm right now. In this case, it's 6,058 kilowatts, and you can see it update as time passes. And then we can zoom into individual turbines to get a more detailed view. So for example, when I select one of the turbines, we can see the power output, and we can see other important values as well, such as the current blade pitch angles, the temperature of the components inside the turbine, and the exact wind conditions experienced by this particular turbine. Over in the power section, you will see that there are 3 power values. There's the observed power, which is the actual power produced. And the 2 other values are based on different prediction models that guess at what the power produced at this time could have been. The physical model uses basic physics and weather. And then there's the data model, which uses machine learning. The big question, though, is how do we make sure that this prediction is working? Anytime the machine learning model fails to accurately track the power produced, we immediately send an alert to the user, which gives them an opportunity to investigate if there are any issues with the algorithm or with the turbine. These alerts are also sent in case there are issues with temperature or just general power production. The second, more detailed investigation can be done when we look into the past. All we have to do is double-click on the power tile, and bam, you can see the historic data for the power produced on this turbine, and you can see the actual observed power alongside the machine learning and physics prediction. For example, in this case, you can see that the machine learning prediction, the power DM, seems to have been quite effective as it's close to the actual power produced. Another important view is this one right here, which shows the power produced by all turbines in the same graph. And this can be used to compare the historic performance of all the turbines against each other. And with that, we are ready to move on to the future. All we have to do is click on this power prediction button, and that kicks off the prediction mode. At this point, what happens is the app fetches weather data from a local weather service and feeds it to the machine learning model to finally obtain the predicted power. And you can see that the clock is flying right now. Why is it in such a rush? That's because we're simulating the next day's power production with the predicted values from the machine learning that we just got. And you can see the play-by-play of the power output of the entire day. And you can see the same data in the chart below. And that sums up all the features of the app. One of the key issues with wind power is that it constantly fluctuates, making it difficult to manage and predict. This app brings together the past, the present, and future data to give a comprehensive perspective of the performance of the wind farm and provide deeper insights into the accuracy of various prediction models. Our hope is to help Doosan optimize the performance of their wind farms and ultimately create a more sustainable future.
Okay, right. Sorry. Second. Okay. So, the reason I like this wind farm scenario is because we've been obsessed with electrical, grid power pylons, and an average power pylon, as simple as it gets anywhere between 25 and 50 different elements. Then those 25 to 50 different elements are increasingly getting more and more complicated and connected both to the power and to the grid. So this is a very typical example where we need to be able to understand not only what can happen to it, if it's rusty, if it's bad or good, but also we need to be able to understand what can happen with it in the context of a bigger model.
Heavy industries.
When it comes in play, the different Azure services, again, we've already established the need to have a very secure and reliable communication between your different devices, your IoT devices, your IoT applications, and the data analytics layer, which basically connects to the way you build and manage your grid, right? And remember, one of the obstacles for making it all super complicated was you can't really predict how much hardware you will need, what kind of people you will need, and how to make it secure while you make it super complicated. This is where Azure Iot Hub provides a cloud-hosted solution, so it connects can virtually to any device, right? And basically, you can extend your solution to the edge with any level of identification per device. It can connect to built-in device management systems, and you can scale it as big as it gets, right? And there is no, and you can scale it up, you can scale it down. So basically, Iot Hub also prevents the #1 challenge to digital twins, especially in modern grid utilities, which is silos. So it's the #1 tool which you basically can rely on without worrying too much about having to think it through for 6 months and then design for another 12 months and then starting to implement something that's super old now before you move on. Iot Hub, Azure Iot Hub, basically enables a real bidirectional communication with any number of IoT devices. Can be millions, can be billions. So you can have device to cloud telemetry, so you can understand what is happening to your devices. You can route to other Azure devices. And one of the beautiful benefits that Microsoft tries to offer and extends, no code. Basically, again, you don't need a very complicated investment into human resources to be able to design it and basically run it. So you can send commands, notifications to your connected devices, build relationships, resend automatically whatever device messages as you need. Also to overcome the problem with this connectivity, which may be not reliable, may be also completely non-existential in some parts of the grid. I'll give an example. In Bulgaria, we had the story of basically we have, it's a very small country, but we still have a number of areas where the actual grid is, which have absolutely no coverage, right? No mobile data, and it's also quite costly and complicated to support, for example, satellite data. So basically, we can rely that if there is disruption of data, we can come to the place, bring our own connectivity and connect information from devices that has been accumulated, or even in cities where we are quite used to data, we also run into a situation where, for example, some of our devices, grid devices, they sit in basements, and there's also quite limited connectivity underground for a number of them. So we need to be able to make sure that our logic is not compromised of how the system operates, and even if we have intermittent connectivity, we also need to be able to plan for that, right? Lately, we run into the increasing problem of security again. So basically, to be able to remotely set up individual identities and credentials is super critical. And it's also something that Azure Iot Hub is able to provide to you. It also can integrate quite seamlessly with another Microsoft tool called Azure Event Grid. And the beautiful thing is that you can also, again, I remind you, it's on the cloud. You can scale it as much as you want, up or down, without planning for costly equipment, which you don't know if you're going to use. And the best part of it, using BI tools, you can also convince your management, well, how to buy it, which is also part of what I do in real life. Now, basically, as we mentioned, in that environment, you don't have the laboratory perfect conditions, whether for connectivity, for you're not insured from loss of signals. plus that also connects to remote updates of devices and security. So basically, we have another wonderful tool by Microsoft called Azure Iot Edge, which pretty much can help you, for example, buffer outbound device telemetry. You can configure target deployment configurations, which basically means that whenever I send technicians to the field, we can specify a list of containerized applications, and we can enable a connectivity for a certain group of devices, because we need those devices to operate autonomously. So I don't need to be able to have a constant relationship with them. Again, security, there is a built-in functionality called Hardware Security Manager, which can run on the device itself, and basically again integrate seamlessly with our system. Another aspect of Microsoft solutions, and apart from being from not having to rely on super trained workforce, which is quite often the case with Google, basically all you have to identify which digital twin needs to be updated and call it into the API, and basically the system self-configures itself. So this is one of the huge benefits, that you can now connect pretty much any data source, bring it in, and it will automatically help you understand if it's good enough. Now, basically, what you can do, again, you can take any Word object, try to configure that, and one of the important things, apart from able to run it automatically, is also to how do you find actionable insights. And this is has been a ongoing problem, because what we currently have is a lot of data. What we don't currently have is smart ideas how to use it. So it's not only about making sure that the grid will not fall apart, it's also, as we mentioned at the beginning, what actionable insights and that we can convert into actions we can configure and extend without compromising the security or the operations of the system, which is the important question. As I mentioned at the beginning, I'm more on the business side of the technical applications of those things, and part of my real world pressure is how to take those technical achievements and how to unlock new smart services. And this is what the whole Azure platform is able to do. It can help you describe, define, and simulate what will happen when you integrate new smart, interesting services. I give an example. We long know that operators, let's say mobile operators, are quite used for decades now to play with different proposals. They can have flexible tariffs, they can add new services, you can configure your services the way you want them right now, and some go as far as helping you define your own individual packets. While it's not that critical if your mobile data is interrupted, although in some instances I know it's quite important. Here we're talking about human lives, and basically the ability to invent new service based on some data patterns identified in a very secure way, that your platform gathers for you, and able to play with it and see what will happen to the system. This is what makes Microsoft's approach extremely important and extremely competitive, I would say, in regards to other similar approaches that concentrate mostly on the technical side of things. To achieve all that and to fix the challenge with how much hardware you need, This is also a readily available solution from Microsoft, the high performance computing, which is basically a complete set of anything you want: computing, network, storage, workload orchestration for high performance applications. So basically, using the cloud approach, you can now build your perfect setup, right? And that's also one of the most appealing things, that you can achieve a very competitive price performance compared to any on-premise option, right? So you can have anything, right? Interconnectivity, end-to-end workflow agility, right? You can achieve production class platforms with a few clicks, and basically incorporate and take advantage of anything. Train AI models faster, automate machine learning, auto scale, and basically also save a lot on DevOps. So it's a very viable proposition, both from cost perspective and also from time to market perspective, especially if you want to not only play with new services but also implement those new services. And here is my favorite part. This is what we try to do in Bulgaria. This is actually Bulgarian power line, and this is the result of information we collect with drones. We have a little startup called Power Drone, and this is the essential tool for gathering any data we want and connecting to any data we want to connect to basically build a digital twin of a power line. Right now, it's an output from one of our projects where our own platform can automatically identify critical elements of the grid. I told you that about can be anywhere between 25 to 50 components on each power line, on power pylon and power line. And this is just a small example of where we sit right now. Where we want to go and is to have an automatic way of collecting data. This is an actual screenshot of what we have as our own platform. So that's why it's in Bulgarian, because most of our clients right now are Bulgarian utilities, which basically automatically can identify which elements to look for and what we're working right. And we also learned to identify what's their status. So we're still in the old age, where our best achievements is identification of, for example, what's the type of the power pylon, and if there is anything wrong with a specific element, like an insulator. And this is what I want to basically run you, explaining the concept of what we have right now before I continue.
PowerDrone is a data analytics technological company using drones and specialized software for an automated power line inspection and other energy assets. Utility and energy companies have to inspect their assets on a regular basis, and they face lots of challenges. The usual on-foot inspection is slow and costly. Areas are hard to access, and grid elements are not properly inspected. The manually collected data is difficult to process and analyze. We are helping utility companies with their regular technical inspections, especially in hard-to-access areas, where we can secure full accessibility to any inspected object and collect high-quality data. The platform can be approached remotely from any point of the world and provides access to the entire analytics and processed imagery data. With our software solution based on AI and machine learning algorithms, we are able to process high-quality data. The application of AI and machine learning algorithms make possible the automated recognition and classification of the different grid elements without a human interaction. The software successfully sorts out the images for the given object, defines its precise GPS coordinates, and defines all attributive and technical information. To secure highest precision, the processed data is validated by an expert verifying the software findings and retraining the algorithms. The excellent visibility and precise identification of the problems point out clearly the need and priority for preventative maintenance, saving substantial budgets for emergency repairs and unwanted shutdowns. On top, we help minimizing the quantities of unsold electricity and unhappy customers. PowerDrone is aiming to automate as much as possible the entire workflow, both in terms of automated data analytics and autonomous drone inspections.
Okay, so basically, we've been there. So, if somebody can appreciate the power of Microsoft Azure services, Azure Cognitive Services, Azure Digital Twins, Azure Iot Hub, is us, because we spent countless of hours putting a human in the loop, trying to, improve things. And it was like an hallelujah thing when, we've realized that these things already exist. That what you see on the screen is an actual attempt to upscale what we do and start building digital twins representations. That is the ring road of Sofia, the capital, and that's a part of a network we're currently examining. And I'm going to show you basically how it looks in real life. We started to incorporate, real objects, and let me see if that's going to happen. And basically, our image recognition capabilities on 3D visual objects, and we're still pending to kind of connect it to Microsoft Azure. But since it's Azure Digital Twins are a relatively new concept, so we're definitely very interested in any help in doing so. This, by the way, has been done with the help of another Sofia, Bulgaria-based company called MYX, that are really becoming an expert in ways of 3D modeling and building digital twin solutions you can actually play with. Let me try to share. How it basically looks like right now. Okay, let me see if I can put it. Yeah, a second. Need to be able to see what I'm doing. So this is what we currently have as. Second. This is what we currently have as a real life representation. And when we talk about a human in the loop, what we need to be able to do at some point is this. I mean, not me, but we might have to include more people, anybody from the urban planning, so they need to be able to see what is happening, nearby, what is happening to nearby infrastructure. And this is like a small representation of what we've defined as a 3D world. But this kind of gives you an idea of what we want to be enabled people to look for. We want to take the people, bring them there, and also, help them understand how it operates, all together with actionable insights. So I guess this concludes my presentation. I'm available on pretty much, that email. Okay, 1 second. I need also to share it. Yep. So I'm available on, no, not that one. Sorry. I'm available on, that email. And that's one of the companies involved that is dealing with this topic, Anthill. So please reach out to me, find me on LinkedIn, find me on Facebook. So far, out of Global AI events organized by Mikhail Matev, we have been extremely successful to find soulmates interested to and able to help us, and some pretty important things were born out of it. So we'll be super thankful and super happy to connect to more people that are excited about digital twins. Thank you.
Hello again. This will be the last session at the first Global AI Night, which we organized this year. And it is exactly about AI and analytic workloads on the edge. It is something pretty actual, and hope you will enjoy this session. We will have some things related to the previous sessions. We will have a little bit also cognitive services, which are related to what Andre explained. We will have a little more from IoT, which is related also to session from Andrei Bachvarov. So I hope that you will enjoy this session. Let's continue with some overview about the session. I will not talk about myself like co-organizer of this event. I think that most of you already know who am I. So we will talk a little bit more about edge analytics, about architecture of systems related to edge analysis, about some specifics when we have computing on the edge. We will go further with Azure IoT Edge because it is a common platform which is shared from different components related to AI and some other groups of functionalities. It is not only pure IoT, and that's the reason actually to have everything on the edge related to Microsoft Edge analysis, also in tight relation to Azure IoT Edge. We will go a little bit more in details about implementation, how it is designed, and we will have several demos. About the demos, there are some specific things. You should have subscription for some preview programs for some functionalities about AI, but in general, I think that we can demonstrate at least some of the features which are interesting and will demonstrate what exactly is the advantage of Azure AI on the edge. So, exactly what is edge analysis? Probably it's good to start with this because years ago, it was something which was not probably considered from industry, from the business, and from software engineers. It is because in the past we have computing, which is actually where we have people who work with computers and where we have input and output. But with the growing of cloud computing, we started to have more and more analytics, which is in different place from the place where we actually have interaction with users, with some other systems, and where we collect some data. That's the reason now to talk about computing in the cloud and computing on the edge. And because when we started with public cloud and cloud computing probably 15 years ago, the trend was to have as much as possible analysis on the cloud. Nowadays, we have this consideration that for some functionalities, it is not needed to have everything on the cloud. Even we have some very good advantages if we can have edge analytics. Edge analytics, we consider like general functionality, which includes also analytics related to artificial intelligence and some other systems on top of Azure IoT Edge in the context of current presentation. Edge analytics started from the beginning of web technology in a little bit different way because we had no pure cloud, but we had internet, we had many websites, and we needed to have good performance
for these websites. So in 90s, for the static content, there already were CDNs, which were related to distribution of static content, so named content delivery networks, and possibility to have many edge servers in different locations, which will be used to deliver this content faster to the end users. It is directly probably not considered with some processing, but it is the beginning of the edge technologies. And later, we had different type of distributed systems. We had peer-to-peer solutions, we had grid solutions, and after 2006, the growth of public cloud stayed very fast. And exactly in this time, we started to consider that edge computing is some kind of analytics which will work in tight relation with our processing power on the cloud. We will talk about how to do that in the best way. What exactly we have like advantages when we have edge computing? We have several things. I will not go into details because we have limited timeline, but we have privacy, which is very important for many systems. You can restrict some kind of some part of data which is needed for specific analytics only in the area where it is considered to be allowed this data to be used. This could be sensitive data related to citizens of specific region, specific country, for example, which need to be in specific place. Also data related to healthcare, which should not be outside of specific, for example, institutions related to healthcare. In general, privacy is one of the biggest advantages when we have edge computing, but not only one. Latency, when we have need to have analytics, which need to have also pretty fast response, is one of the other big advantages from edge computing. Imagine that you have production line and you need to have fraud detection, for example, and you need to have very fast response. In this case, it is much more difficult to have good SLA with cloud computing, and you have also some limitations regarding to time for transportation. You can have some issues with connection, so it is pretty difficult to have very fast response and to have commitment that this fast response will be always with specific ranges which are acceptable. Reliability is related to several aspects, but one of the most important is related to connectivity. When you have options for analysis and computing power on the edge, if you have some issues with connectivity, actually you can have all or part of functionalities available in any moment, despite that you have some issues with connection to the backend services. And the most important for modern solutions is to have tight relation between what we have on the back office in the cloud and what we have on the edge, and to have the good balance between analytics in these two layers. This is the advantage which we need to have for modern solutions. Let's go ahead with several additional details. We can have different devices with options to be connected directly to the cloud, and devices which need to have other devices like field gateways, and also devices with different computing power. Usually we can have different topology for our solutions on the edge, but depends on how we have the specific design. In any case, we need to have field gateway device, which provides connectivity to the backend via internet connection. Usually, this field gateway is edge device, not always, but pretty often. And we will see later the advantages if we have the computing power in the same place where we have also connectivity. But we can have also different types of devices connected to our field gateway. We can have some devices with own computing power, with own processing. We can have devices which will rely on third devices connected to these devices for processing. For example, we have very high variation of different options. It depends on specific requirements for the system, and that gives us actually very good flexibility to adjust the price and the computing resources which we need for modern solutions. How exactly the workflow usually is presented? We have different things which collect information. They're connected with specific sources of information. For example, there could be interaction with users. They can have sensors which just to collect some metrics from different machines or from other solutions. But after these devices, we have edge computing. There, exactly, we have the decision how this data should be processed. So where we have edge computing, we have one of the most critical logic for these solutions, because part of processing will be on the edge, part of the processing will be on the backend in the cloud. That's one of the reasons for modern solutions which implement edge analysis, exactly part related to edge analytics, these devices and what we run on top, software responsible for this, to be very critical. Usually, when we have edge-based solutions, we initially consider IoT, mostly because many solutions already running on the cloud and having such kind of edge processing functionalities are considered like part of IoT solutions. But last several years, especially with growing of functionalities and powers which we can have on the edge with new, more powerful devices, we have more and more different options to have analysis related to different subparts of artificial intelligence and some other domains of technologies. What exactly we have as overall design? For Azure, we have tightly related Azure IoT platform with Azure IoT Edge from one side. We have connectivity which is implemented in a common way, and we have here on the edge device also the common platform which is used for different models with different types of analytics. So we can say that Azure IoT Edge is always related to Azure IoT in general, like platform. That doesn't mean that we need to have only IoT solutions where to collect some information and analyze it as in the traditional IoT solutions. We can have video streaming, we can have almost any kind of analytics on the edge based on AI functionalities which Microsoft offers in containers on top of Azure Iot Edge platform. So we have connectivity between Azure Iot Edge platform and what we have on the cloud with specific model on the edge, which is Iot Edge Hub. We will talk about it later, which is connected with Microsoft Iot Hub. Andrei already explained some things about Iot Hub, but we have these functionalities out of the box, and we can be focused on specific functionalities which will give us additional value when we are using Azure Iot Edge as a platform. We can run different workloads. We can run everything on top of already ready for use platform in the context of Azure Iot Edge. Using this approach, we can reduce the bandwidth. It is one of the main advantages also of these platforms. You can have more processing on the edge. You have no need to send all data on the cloud, and your bandwidth actually can be reduced. You will pay less for connectivity, and you will have also faster response. Your latency will be actually low and smaller. And you can have also in this platform functionalities which you will get out of the box instead to implement it for your edge solution. You will have gateway devices already implemented. You will have centralized option for deployment of models. You will have availability to create third-party models. You will be able to support offline work. Even here for offline work, the platform offers quite good out-of-the-box option for models which the platform actually expose, like logic to work on the edge or on the backend, like distribution of the load. For custom models which you need to implement, you need to be responsible for this logic, of course. Do we need to use such kind of solutions always, or just in some cases? We can say that for many cases, if we have also edge for our analytics, we have advantages. It is not necessary to have this on 100% of the cases, but in many cases when we want to have actually faster response, when we have analysis, when we need to have better security, better privacy, higher SLA options for working offline mode, and actually we will have in general better reliability. We can have, of course, many additional options which will actually require exactly to use edge solutions. When we have solutions on top of Azure Iot Edge platform, we have the main communication between devices and backend services the IoT Hub for some specific functionalities, like, for example, software update and some other things. We can use different channels for communication. It is not expected for non-general communication related to gathering of data, different types of messages and commands, always to relay to one communication channel, but good practices recommend, when it is possible and when it is reasonable, of course, to decrease number of channels for communication between devices and backend. There are different solutions for edge analytics. You can see the several trends exactly related to this kind of solutions. First, we have such kind of common platforms for IoT and AI edge analytics, not only in Azure, also for several other solutions from big vendors. But my personal opinion is that Microsoft Azure IoT is one of the simplest, easiest for learning solutions. So you will start faster, easier. You can deliver in the shorter timeline, and actually you can be focused mostly on additional business logic and functionalities instead to implement some general functionalities which in other solutions not always are 100% supported. Almost all business domains already are related to IoT Edge analytics, and I will not go into details here. Initially, these solutions started with manufacturing, with automotive industry, but now we can have it almost anywhere. Let's now go into some platform details, and after that, we will have specific use cases and demos. When we talk about edge analytics and Microsoft Azure, as I already explained, Azure Iot Edge is the solution out of the box, which you need to use like foundation and to build on top of this solution your software. There are several groups of components which you need to know, at least in general, how these components work to be possible to implement your own solutions. From one side, we have different IoT Edge models. These models are containerized applications which are hosted into Docker-compatible containers. And we have IoT Edge runtime, which is responsible for actually all supported functions to run models on top of this runtime. We have here Mobi framework. It is actually a lightweight framework for running of Docker-compatible containers. We have some libraries and several key models which we need to implement communication between other models, consider device and other devices, and device and IoT Hub if it is needed. So we will discuss about these key components, and we have also another component which is responsible for running of models which we have in our edge device as models implemented on top of Azure Iot Edge. Additionally, we have monitoring, which is implemented with Azure Iot Edge. For monitoring, we have cloud interface. You can use Azure Management Portal to have monitoring and management of our edge devices. These functionalities are available also with Azure CLI. When we have traditional flows for IoT solutions and in general flows in IoT, we have Iot Edge, and in the current case, Azure Iot Edge, in between our devices and Azure IoT models. It is more specific for Azure IoT because we have ready for use, pretty well implemented platform, but in general, all solutions demonstrate similar concept. What exactly we have with Iot Edge models? We have models which are containerized applications, and these models actually communicate between and with other components of the Iot Edge via Azure Iot Edge runtime. So you have no direct communication between models. You have no need to consider about this. For this direct communication is responsible Edge Hub. We have for runtime environment additional benefits which are related to security. We have common interface to have access to hardware security models, to some secrets, certificates, and whatever is needed on device. About Edge Cloud interface, I will demonstrate how you can work with this interface exactly with Azure Management Portal, but you will be able to manage device provisioning, software update, maintenance of models, uploading of new models, restarting of models, and some other functionalities which are critical to control, monitor, and maintain models on edge devices. What exactly is good to know about Iot Edge Hub? We have just part of functionalities of Azure Iot Hub. We support only MQTT and AMQP protocols, not HTTP. And we have very good common design to be possible without specific not needed effort to connect Iot Hub and Edge Hub. Edge Hub is one of the models which are part of Iot Edge runtime, and it is installed on your device when you actually have Iot Edge deployed on your device. Iot Edge Hub is responsible also for functionalities related to field gateway when you have edge device configured as field gateway. There are several different types of configuration. Your field gateway can be transparent. You can actually have configuration where to have change of identifiers of devices. You can change protocols also. We can consider these things a little bit later in our presentation. What additionally is important for our Iot Edge as foundation knowledge? When we have Iot Edge framework on some devices, we need to use also IoT Hub and to register devices in a similar but slightly different way from devices which you have registered like non-edge devices. So we have for edge devices separate options in our Azure IoT Hub, which we will see a little bit later on the demos. If we can consider the overall design, you have these modules which can be custom, which can be from third-party vendors, and of course from Microsoft on top of Edge Runtime. And we have these two critical modules, IoT Edge Hub and IoT Edge Agent. Agent is responsible for running of models on top of IoT Edge runtime. And we have, of course, specific unified interfaces, how these models to communicate in between, how to communicate with secure storage, and how they actually have some functionalities related to update, stop, start, and different maintenance-related functionalities. About field gateway configuration, as I already explained, we can configure our edge device, if it is Azure IoT Edge device, based on specific functionalities on Edge Hub. So this is probably good point to remind when you have IoT Edge platform. Doesn't matter if it is for edge analytics, non-related to typical IoT functionalities, or we have pure IoT solutions, that we need to use this component to connect our edge device to the backend. And we need this component to provide communication between different models. It is transparent. If you are a software developer who need to implement some functionalities related to business logic on your device, you have no need to consider implementation of these functionalities. There are some good advantages also if you need to have different logic and different settings for different regions or different organizations. I will use the term tenant instead organization because it is more technical. So if we need to support different tenants and also different regulations for different countries in our system, and we have everything on the cloud, it is sometimes more complex and difficult to support all this logic on the backend. But if you have part or all of this logic on the edge, you can have different models which will run the exact logic for specific tenant or for specific region or country. In this way, you can decrease the common complexity of your solution, which actually will make implementation and support of this solution much simpler. Let's go a little bit further to show you several things which actually are related to use cases which we will have. First, when we have edge strategy, we need in any case to consider several things. Edge devices, we already discussed. We need to have devices which to support like hardware compatibilities, IoT, Azure IoT Edge platform, and also like computing resources to be enough powerful, and we need to consider this in the overall solution. We need to have device registration in the context of how we will manage these devices from the backend. We need to have also in our solution module development for custom functionalities. Everything should be implemented in this way. If you want to have not related to Azure IoT Edge implementation of specific processing logic on the edge, it will be not effective if you are using IoT Edge platform. If you are using pure custom solution, this could be specific case if you have reason to do that. But if you are using IoT Edge framework, really it is not good practice to go outside of the mainstream approach how to implement custom functionalities. And if you go in this direction with Azure IoT Edge and implementation of all logic inside modules, you have centralized deployment, upgrades, everything. Security also is related to this concept. We have several groups of components which we can use on the edge. One of these components is Azure Stream Analytics. Azure Stream Analytics, as many of you probably know, is the main service for stream processing and processing in real to in near to real time cases. In this service, you can have configuration where to use functionalities on the edge. You can make it in a way where balance between what is processing on the edge and what is processing on the cloud will be transparently managed for you. So you will be not responsible for this. You need just to make the settings for the edge part. Unfortunately, currently there are some changes in Azure platform. So in the latest updates, I think there are ongoing changes, and there is one issue in configuration of Azure Stream Analytics on the edge. But in any case, I will try to show you the concept. Job, which we will see, makes the distribution of the processing logic automatically. We have for edge job some limitations, but in general, we have pretty good and powerful option to have stream processing also on the edge. There are several types of inputs and outputs which we can use on the edge. Edge Hub is the main considered option. We can, of course, use IoT Hub, Event Hub, and we can have as output again Edge Hub, and to be possible to send our data via Edge Hub whenever we want. We have SQL database. We can put it also on the storage or Event Hub. So this is the main concept, how Azure Stream Analytics works when we have edge solutions. It is service which works on both sides, on the backend and on the edge device, and it is implemented with very good user experience to be possible, easy to set up and manage this. Another group of services which you can see are cognitive services on IoT Edge. cognitive services need to be configured in implicit way, not like in explicit way, not like Azure Stream Analytics in implicit way, where we do not consider separate deployment and configuration of the cloud part and edge part, but for cognitive services, you need to have it. You need to have deployment of cognitive services on the cloud, and you need to have specific model also on the edge device. And you need to configure your edge device to work together with your deployed in the cloud service. We will see some specifics here. Some of cognitive services are in preview. For those services which are in so-named gated containers preview, you need to have specific request to Microsoft where to fulfill your company. You need to have company account, company subscription, and this company to be Microsoft partner or Microsoft enterprise client to be possible to be included in the preview. For other services, actually, it is not expected to do it in this way. And we will see, of course, in the demos, pretty straightforward how you can make settings on the edge where to use connection with the already deployed in the cloud gateway service, and to have this distribution of the load in a similar way, like I already explained for Stream Analytics. Just here, you need to provide this connection. And yes, we can, after that, using different options for REST API to be connected to these services, even directly with API calls. We can see how it works. About machine learning, it is similar, but it is slightly different. You need actually to implement the following flow, where you need to have actually service which is deployed into model on the edge. But to have this service, you need to have model in advance. You need to train your model. You need to create this service into container as model for Iot Edge and to deploy it. And you have options pretty straightforward to have updates of your machine learning models which you created on the edge. When you have updated these models, when you have improved models, you can redeploy this on the edge. So this is probably the most important. About edge analytics in real world, we can talk a lot. Just to explain that nowadays, many companies related to retail, for example, fast food, automotive, use this on top of Azure Iot Edge. One specific example is Starbucks, for example, Mars Drinks, many manufacturing companies, they use their solutions, their machines. You have, for example, Starbucks machines, you have actually devices which are running on top of Azure Iot Edge. Now it is better to continue with several things related to how we can implement our edge solutions. I already created several things in advance, but we will discuss about specific options. I already created Iot Edge Hub. We'll try to make just a little bit bigger the size of components. We'll try to refresh it. When you have, yes, my session is probably need to be renewed. When you create Iot Hub, you have for edge devices option to configure with this cloud interface details which are related to your models. We have already several devices which are running here. You see that always we have Edge agent and Edge Hub deployed, and I added two additional models. One is related to so-named gated containers, which I mentioned already are a specific preview, so you need to have request about this. And another one is pretty similar model related to sentiment analysis from cognitive services, where you have several things which you need to configure. You need to configure what exactly will be the communication protocol, ports which need to be used, and some other settings of your container, and you can do additional environment configurations. Some of environment configurations are related to specific model, but often you can add additional variables for specific configurations. How this works? Imagine that, for example, we need to create a new cognitive service. For example, if we create a cognitive service, we need, of course, to choose our main settings of this service, where this should be deployed. Of course, we need to consider the closest region to our edge devices. Here I have West Europe for my setup. We'll put here some name. You need to choose pricing TAR. If you need to configure for automated deployment some tags, for example, you can use it, but we need also to confirm terms of agreement. When we have such a solution, deployment in the current case will be pretty fast. You need to go to keys and endpoints. So you have two things which are important. The key, I will put it outside of the shared part. And also the endpoint. We will use this service with our model deployed on the edge. How we can deploy our edge models? We have actually two possible flows for this. Let's go here to my edge device. You have option to set models. Here, you can add three types of models. You can add IoT Edge model, which is custom. We can add the URI of our model, the URI to repository from where to get the image for container, and it is mostly for custom logic. We can use Azure Stream Analytics. Unfortunately, in the short timeline, I will be not able to cover this end-to-end. And we have marketplace model, where depending on what we have as need, we can find possible options. For example, edge models, sentiment analysis. This is what we already have. I'm using this demonstration with this model just because this model is in general availability. You have no need to make any specific requests for your organization to be included and your account to be possible to use this model. So you see that here you have automatically some things. You can need to add some additional things. You can see for environment variables. Here, you need to add endpoint, your phone and billing endpoint. You need to add your API key. You need to update it. Eventually, you can also have specific routing if you need to have specific routing between models from where and to where you can actually have incoming and outgoing messages. In this case, we have no need to do that for such kind of model. You can create it. When you create it, you will have also model twins where you see the whole your information. In the current solution on the edge, it will be not possible now to run the second model because both models are using the same port, 5000 by default. It could be configured, of course. We can make additional configuration for our device, we will be able to use set models, and to do the set models here, you will be able, let's try it for the new one. If we need to have some changes, here we can change the settings for port protocol if it is needed. If you need to have some additional configuration, you can add it into the model twin. In the current case, I'm just demonstrating this, not need to change it, because to change it in a way to be possible to work with both models, instances of cognitive services on the edge for sentiment, we need to consider also configuration of our edge device. For the edge device, currently I'm using deployed virtual machine, where on in the networking we have different rules with for inbound and outbound communication. So you need to configure these details also. And at the end, when your model is ready, for example, I already have such kind of deployed model, you can access it on your device. I already prepared everything which I need. I got the IP of my device from settings for the virtual machines, I see. And you can actually test if your model works. Depending on what you need to have, like functionalities, you can actually test with your custom data, not only with what is demonstrated here, how this model works. But in general, we have the same concept for all cognitive services. We need to deploy on the cloud service instance. We need to connect with this service instance model, which is deployed on your device. Cognitive services works in this way. Azure Stream Analytics is configured only one time. So for you, what is running on the cloud is transparently. And for machine learning models, you need to have more custom settings, because the whole life cycle will be actually part of your implementation. You need to create the model, train it, you need to create the container where to host this service, and to deploy as a model to Azure IoT Edge platform. So this was the most important, which I wanted to share about how we are running AI-related models on the edge. We can make almost any kind of scenario supported from Azure AI components around cognitive services. Some of these components, as I mentioned, are still in preview, so it is not possible to have it in general availability, but you can expect it in the near future to have these components also available for anyone with production quality. Thank you very much for attending this presentation, and also for attending the whole this AI Night conference. I really want to have your feedback, so we will expect your feedback for this event, like first one for Global AI Night initiative. We promise you to have more and more events around AI, analytics, cloud, mostly in the Microsoft technologies. Well, we are trying to do that, and we will have 1 or 2 events in one or another format every month. Stay tuned. In June, we will have in Bulgaria huge event, our AI and IoT Summit, and also in June, we will have one global event. We will have global AI streaming worldwide, another event. For this event, we will share pretty soon additional information. Thank you very much for attending Global AI Night Bulgaria, and hope to see you soon next month.